much. Thank you for your nice introduction. Let me first thank UPL University, Mr. Panjwani, Mr. Professor Wag for your kind invitation and allowing me to select a suitable topic for today's presentation. Well, the topic which I have selected is compressed biogas, a sustainable biofuel, emerging opportunities and production technologies. Let me very briefly introduce you Vasantdada Sugar Institute. Probably most of you may not be knowing. Sir, as discussed in the morning, we are an institute which is formed and funded by the industry. So we work with the industry on a very routine basis. In fact, most of my staff is always on the visit to the sugar mills, and we are involved right in the process troubleshooting, process improvement, technology transfer. So our linkage with the industry is very high as compared to other academic institutions. Of course, we are also involved in academic. So we have a lot of postgraduate academic courses related to the sugar industry. And of course, on the R&D front also, we do a lot of R&D activities. So, okay, so I will start with a brief introduction of one of our project. We were working on this project for last few years, and it is an Indo-UK funded project. From Indian side, it was the DBT, and UK side, it was UK Innovate, which funded this project. The Queen's University was the lead institute, and from Indian side, we were the lead institute. And this project was related to valorization of sugar industry waste. So that's why the concept is VIVA. VIVA is valorization of waste, and it is a VIVA biorefinery concept. So you can see on the left hand side, there are various waste which are produced in the sugar industry, which we try to transform into value added products. So we use different kinds of pre-treatments. We use hydrodynamic cavitation, anaerobic digestion, acid alkali pre-treatments, and thermal pre-treatment. We have done, all the consortium of this project have done a lot of work on biotransformation, process intensification and downstream processing. And you can see on the right hand side, we have worked on various value added projects. One of the product is of course the biogas or bio-CNG, on which I am going to speak on. So other products are also very important. So we call it as 2G, second generation succinic acid, second generation lactic acid. We also work on the other biofuel like biobutanol, and then recovery of the lignin. And of course, there were 3 universities from the UK side, and Indian side we were IIT Bombay, IIT Delhi, and VSI and Indian Institute of Petroleum. We worked on this project. So it is basically based on sustainable, resource efficient valorization of the sugar industry waste in an integrated and multi-output production chain. So you can see this is the concept on which we started working. And coming to the importance of compressed biogas, probably most of you must be aware that we import almost 50% of our natural gas and around 77% of our crude oil. The target of Government of India for this year is that they want to reduce the import of natural gas and crude by at least 10%. In fact, our contribution of gas in the Indian energy matrix is 6.5% only, which they want to improve to around 15%, whereas the global average is around 23.5%. The estimated CBG potential of our country is somewhere around 62 million metric ton, and when we produce this CBG, we will be also producing a very important byproduct called as biomanure, and the capacity, generation capacity of this biomanure will be around 370 million metric ton. In fact, sugar industry is a very valuable kind of source of the feedstock for CBG production, and we probably some of you may be knowing that we produce almost 104 million metric tons of sugarcane bagasse and about 14 million metric ton of press mud cake. All of this can be used to produce compressed biogas. Along with we also produce sugar, cogeneration power and ethanol. So coming to the importance of CBG, it has got a lot of advantages. It is import reduction, then it can save foreign exchange, it will strengthen our energy security. This will allow us to use different types of agriculture residues, cattle dung, municipal solid waste, vegetable market waste, which can be used to produce the compressed biogas. And this will of course definitely reduce our emissions and pollution, and in addition to that, this will also improve our rural employment, and this will also result into the increase in farm income of our farmers. So this will also help us to fulfill our national commitment in achieving the climate change goal. As probably you must be knowing, we have to achieve net zero by 2070, and it will also be helpful to go for our carbon neutrality. In fact, compared to gasoline, CBG will result in almost 90% reduction in CO2 emissions. So coming to the government initiative, there is an initiative by government called as SATAT, that is Sustainable Alternative Towards Affordable Transportation. And this is aimed at providing developmental effort for the benefit of not only the vehicle users but also the farmers and the entrepreneurs. So there is a good possibility that many of young people can become entrepreneur and start this kind of CBG projects. In fact, this CBG produced will be transported through the cascade cylinders to the network of oil marketing companies. In fact, one can in future also can put this CBG into the gas grid, and in fact Gujarat is they have a well established gas grid, so one can also inject this CBG produced into the CNG gas grid. It is planned that by 2025 they want to set up almost 5,000 CBG plant. At present probably we have around under Satat program around 50 plants, and non-Satat maybe around 20-25 plants. So they want to go for 5,000 plants. So there is a big scope for development of this kind of technology. There is also very good support from Government of India. For example, very recently they revised the price of CBG, which is to be sold to the oil marketing company. Previously it was 46 rupees. Now they have increased it to 54 rupees. And this will be for next 3 years, 10 years. And in fact now they have linked it to the retail selling price of CNG. So if the retail selling price of CNG increases, the CBG price will also accordingly increase. Then there is a notification from the Department of Agriculture and Farmers Welfare that the digestate which will come out of the anaerobic digestion of particularly from the biomass such as bagasse or press mud cake or any other agro waste is now approved under the fertilizer control order as a fermented organic manure. So this is a very important kind of notification which has come out, and this is going to be very important in future. In fact, I have said that it is under consideration, but I understand now Ministry of Chemical and Fertilizer is now providing a marketing development assistance of rupees 1,500 per metric ton of fermented organic manure. So this is going to be very important, and these projects are now under the priority sector lending. So one can go to the banks and easily get the finance for this kind of projects. There was a central financial assistance which was available, but now it has been withdrawn. But I am very sure, because we have been interacting with the central government people, and it is going to again introduce in a different form probably. So government is going to provide the financial assistance for this kind of projects also. Coming to the CBG characteristics, most of you may be aware of what is biogas. Biogas contains around 55 to 60% methane. around 40% carbon dioxide, some trace amounts of water and hydrogen sulfide, and one has to remove all these gases such as hydrogen sulfide, carbon dioxide, moisture, and then compress the gas which is enriched in methane. So the methane has to be minimum 90%, then compress it to 250 bar and put it into the cascade of cylinders. The minimum capacity should be around 2 tons per day. In fact, you can see the calorific value of CBG and CNG. They are almost equivalent and better than the petrol and diesel. And in the middle table, you can see the methane content should be minimum 90%. But in the anaerobic digestion, we generally don't get the nitrogen and oxygen unless it is introduced. So if it is not there, the carbon dioxide is just 4%. That means our methane content can go up to 95-96% also. And that's why the calorific value of CBG can be better than CNG also. In fact, we have experienced this. We have now almost 4 or 5 plants running in Maharashtra in our sugar mills. And there we find that the performance of the vehicles which are using CBG in place of CNG is much better than the CNG. So this is the advantage of CBG in probably which will be counted in future. Coming to what are the different feedstocks which can be used for CBG production. Of course, our emphasis is more on the feedstock which are available with the sugar industry, but there are many other feedstocks also which are very easily available for producing CBG, and one of the important aspect of this is the volatile solids in that part of the feedstock. Volatile solid is nothing but the organic component which can be converted into biogas. Some components are easy to break down, but some components can be difficult to break down. But you can see that the sugarcane bagasse, press mud cake, these are the sugar industry waste, but cow dung, chicken litter, then municipal solid waste is another very important kind of feedstock which is available. Then probably you must have come across that some of the farmers are now going for Napier grass, and this will be exclusively cultivated to produce CBG. So we have some regions in Maharashtra where farmers have shifted to Napier grass production, and there are some CBG plants coming on the basis of availability of Napier grass. Rice straw, one of the biggest CBG plant which is coming in Punjab, where they will be using rice straw, which is the, probably most of you must be aware about this, which is causing the pollution problem in Punjab, and this can be used to produce CBG. The Verbio, that is a German company, which is installing a 33 ton per day CBG plant, so they will be using rice straw to produce CBG. Then there are other kinds of numerous other feedstocks are also available. For example, the vegetable market waste also can be used to produce CBG. In fact, this table gives the reported biogas potential of different feedstocks, and you can see that we have some experimental determination which is called as biomethanation potential. So experimentally, in a small scale, we can determine what is the potential, and of course there is a theoretical potential also. For example, for rice straw, you can see that the potential is somewhere without any kind of pre-treatment, it is 282, and it can go to around 347. So Verbio plant, where recently we have visited this plant, and they are claiming somewhere around 300 meter cube per ton of the rice straw. So you can refer to this table to calculate what will be the potential. Of course, it depends on what are the different pre-treatments you are going to use, and these pre-treatments are very important. This will also affect your cost economics. Coming to the sugar industry feedstock, you can see that with press mud cake, our theoretical potential is somewhere around 130 to 150. Our target at VSI in this Viva project was 120, and we have achieved this 120. And with sugarcane bagasse, of course, the potential is very high, around 450. Our target is 370. Right now, we have achieved somewhere around 151. But there are claims by some other technology providers that it can go even up to 300 with their technology. So, with the use of this sugarcane bagasse, as probably you know, these are the lignocellulosic biomass, and here the particle size is very important, and it is not very easy to reduce the particle size, and of course the pre-treatment. So these are the main aspects in considering the sugarcane bagasse and trash for the CBG production. Coming to the press mud cake, the quality of press mud cake varies from region to region. It varies from place to place, and with respect to time also, the press mud cake can get decomposed, so the volatile solids can go on reducing if you don't take proper care in the preservation of the press mud cake. So coming to the overall picture of CBG production, you can see that there are different feedstocks which can be used. It is not necessary that you use only one feedstock. You can go for co-digestion also. So there are few plants which are coming on the basis of this co-digestion. So depending on the feedstock, you will have to carry out certain pre-treatments, and this pre-treatment has to be cost effective and innovative also, so that you get proper amount of the biogas generation of the theoretical possible. Once the biogas is generated, of course there are technologies to purify. I will be discussing few of the technologies here. And then it is compressed and put it in the cylinders, and then it can go for different kinds of application. What I see is that the digestate which comes out of the anaerobic digestion is now very important. It has to be decanted, and one can separate it into the solid and liquid fractions. And in fact, we are working on these aspects also. Our agriculture department is working on the evaluation of the efficacy of this kind of products, and we find that this is going to be the game changer in the future, and this can add to the returns or the cost economics of the CBG project. In fact, with the surplus agro residues such as rice straw, wheat straw, corn cobs, the potential of CBG production is around 20 million metric ton, and with the sugar industry, with the spent wash and the press mud cake, and if you can use bagasse also, we feel that almost 5 to 10 million metric ton of CBG can come from the sugar industry. In fact, some of the sugar mills, I was yesterday visiting one sugar mill, they are planning to go for CBG production in Gujarat also. In fact, as I told you, our yields are somewhere around 302 meter cube per ton of dry bagasse and around 480 meter cube per ton of dry press mud cake. So what are the different technology components for the CBG production? The most important, particularly with the municipal solid waste or vegetable kind of waste, is the source segregation, and that is the key to the success of the this kind of project. Very recently I went to Germany and Austria to see some of their projects, and because their source segregation is very perfect, they are able to process the feedstocks into the CBG production, and they are using municipal solid waste, they are using supermarket vegetable waste, they are using the animal slaughterhouse waste. So there the source segregation is very important, but apart from source segregation, the logistics, the collection and the storage, I mean, you have to have the feedstock available for round the year production, and for that you have to store your feedstock properly so that it doesn't get degraded, it doesn't lose its volatile solids. The pre-treatment, particularly in the lignocellulosic kind of feedstock, is very important so that you increase your biogas yield. And the central and the heart of the system is of course your biogas plant. So So you have to maximize your yield of biogas from the given feedstock, and there are a lot of technologies which are coming in. A lot of technologies are still under development. So this is a heart of the system. Then of course, as I mentioned previously, you have to remove hydrogen sulfide, you have to remove the carbon dioxide, and a lot of new technologies are available in this area. Then go for the compression to 250 bar, then go for the decantation to produce the solid liquid fractions, and particularly the solid fraction. At least right now we are doing solar drying, but we can use the other kinds of drying also to produce this fermented organic manure, and liquid fraction is also very valuable kind of byproduct of this industry. So in fact, in this Viva project, a lot of our partners and we have worked on different kinds of pre-treatment, and you can see that for lignocellulosic, the mechanical pre-treatment is important, but we have worked on hydrodynamic cavitation, hydrothermal, acid alkali. We have done extensive work. Of course, acid alkali will not be useful for the anaerobic digestion because that will increase the inorganic load into the digester. But there are other companies which have used ammonia fiber explosion, enzyme treatment, and microbial pre-treatment is also being used. So you have to use a specific pre-treatment. We have done extensive work on hydrodynamic cavitation, and in fact, very briefly explaining this, it is a phenomenon of formation, growth, and rapid collapse of cavities. So this collapse of cavities generate localized very high pressures and temperatures, and localized shear, and they also lead to the formation of very active oxidant hydroxyl radical. These shear and radicals, they are responsible for pre-treating the lignocellulosic biomass physico-chemically and favoring the utilization of this biomass. We have also worked on steam explosion, but this is a kind of costlier technology. It is a treatment in which biomass is exposed to very high temperatures and pressure for a very short period of time, and this pressure and temperature is then quickly released, causing an explosive effect on the cell, and this helps to treat the biomass to produce the maximum biogas. And of course, as I said, alkali acid we have done. Of course, we have used this treatment for what we call as second generation ethanol production, but not for the CBG production. Coming to the anaerobic digestion, probably most of you must have seen this in the literature. This is the basics of the anaerobic digestion. In the morning, Professor Pandit was discussing about the growth curve of the microorganisms. So, in fact, this is not a single pure culture technique. This is an mixed culture fermentation where different kinds of microbes they work together in a symbiotic relationship as well as they work in a consortium. So there are different kinds of reactions which take place. One is hydrolysis followed by the acidogenesis, acetogenesis, and finally the methanogenesis. Probably methanogenesis is the rate limiting step in this. Of course, there are a lot of details one has to go through this basics of anaerobic digestion. Because of the time limitation, I will not explore this, but this is the most important thing which you have to understand if you want to run your anaerobic digestion. There are different types of digesters available. As a sugar industry, we are very familiar with using the sugar industry waste, which is called as spent wash. But the other feedstocks are slightly different in the spent wash because it contains a lot of suspended solids. So we have to design the digester. The configuration has to be customized to handle the very high load of suspended solids and maintain homogeneous conditions with the required retention time. The retention time in this case can vary between around 25 to 40 days also. So there are different types of anaerobic digesters which are available. These include the CSTR very common kind of digester which has a central agitation and submerged lateral agitator systems. So many of the CBG plants, they are based on these CSTR digesters. But there is a company called Praj Industries, many of you may be knowing, based in Pune. And they have collaborated with a US company, and they are offering what is called as mixed plug flow reactor, which involves the axial mixing with the use of gas. So this is the diagrammatic representation of the mixed flow plug flow reactor, and it is some kind of underground kind of construction, and this is supposed to be one of the very effective technology. And there is also a dry fermentation kind of technology, and this is again CSTR, but here the feed is in the solid form, and it is fed with the help of a screw conveyor. So there is one German company in India, it's called as JF Biogas. They are offering this kind of technology. Then we were interested in find out a technology which will be useful for both spent wash and the lignocellulosic biomass, and we have identified one technology from an Austrian company. That's why we went to see this technology. It is called as hydraulic digester, and you can see the figures. There are no rotating parts inside the digester. Whole of the digester gets mixed with the help of certain kinds of control valves, and the increasing the gas pressure, and then suddenly releasing the gas pressure to do the mixing of the digester. So these are the kind of digesters. There are other digesters configurations also available, such as biphasic kind of digester. So the reactions are carried out in the two phases. So these are some of our results in the Viva project. We have now pilot digesters also running on the use of the press mud cake, as well as on the use of bagasse, and also on the co-feeding. So you can see that with press mud cake our yields are somewhere around 480 meter cube per ton of dry press mud cake. With bagasse it is somewhere around, it was 251, now it has improved to around 300 meter cube per ton of sugarcane bagasse. And we are doing co-feeding in one of the digester, one of our pilot digester of 50 meter cube. We are doing co-feeding of press mud cake and bagasse in the ratio of, we have optimized the results in the ratio of 3:1, where we are getting a yield of around 370 meter cube per ton of this mixture of press mud cake and sugarcane bagasse. And this is the hydrodynamic, very simple unit, and this is of course developed in the Viva project, patented by the Queen's University, and they have given this unit to us, and we are now running these pilot digesters 50 meter cube using this hydrodynamic cavitation. So what are the important parameters in the cost of production which can affect your CBG cost of production? Is the feedstock preservation and characteristics. This is a very important aspect, particularly with municipal solid waste, agro waste, particularly the vegetable waste, slaughterhouse waste, cow dung, and other, even press mud cake also. So feedstock preservation is very important. Then pre-treatment cost. Then the yield of biogas. With press mud cake we have seen it varies from 80, and some people are claiming 140 also. So this has to be optimized. With sugarcane bagasse and trash, some people are offering 375. As I told you, our results are very low at about 150, but we are still trying to improve on this. The biogas upgradation technologies, removing H2S, removing CO2 are also very important, and the compression cost, and of course the cost of electricity, and they are very important from the cost of production. And then with the biogas upgradation, what is your methane loss and what is the final CBG quality you are going to produce? This is all very, very important. And as I said, price realization of fermented organic manure and soil conditioner in future, they are going to play a very important role in the cost of production of CBG. Now coming to the CBG purification technologies, the most important is the removal of hydrogen sulfide, particularly with spent wash and press-made cake. We get very high levels of hydrogen sulfides of about 35,000 to 40,000 ppm. Also with vegetable waste and other waste, with agro waste also, it can be in the range of 800 to 900. But with the sugar industry kind of feedstock, we are getting very high levels of H2S. So we have to remove this, and this is the technology which has been developed by Indian Institute of Science, ISET process, which is based on redox reaction of chelated polyvalent metal ions such as iron. So this is the ferric, reacts with the sulfur ion of the H2S in the aqueous form, and ferrous is converted to ferrous, and the sulfur gets precipitated. And so these are the scrubber and pre-scrubber reactors in which this reaction takes place, and this precipitated sulfur is then removed by the filter press, and the wash which remains goes to the regenerator where air is introduced. So air will oxidize the ferrous back to the ferric, and this is the reaction which is carried out in this regenerator, and then the liquid is again recycled back. So here we regenerate the chemicals, so there are absolutely no effluents generated in this, one of the very potential technology. This is indigenously developed by Indian Institute of Science. And of course we have seen in Austria and in other places where the H2S levels are less, they are using this kind of biological desulfurization. So there are certain kinds of microbes, particularly thiobacillus kind of bacteria. So they are put into this reactor on the support of some kind of media, and the liquid then percolates from the top, and the air goes from the bottom to the top, and the reaction takes place, and it converts the H2S into the sulfur and sulfates. So it can tolerate about 20,000 ppm of H2S, and it can bring down the H2S to around 50 ppm. Then we have used this technology in one of the plant. It is an old plant, but this is also using, but this is quite slightly costlier kind of in terms of operational cost. We use caustic and H2SO4. So by using this caustic, we try to remove H2S. So H2S is absorbed in the caustic, and it is converted into the ammonium sulfate. So we have the ammonia also getting removed in this kind of reaction. So these are some of the technologies. There are many other technologies available. You can see in the international scenario, there are a lot of good technologies available. There is a biological fixation. Water scrubbing is also one of the technology which has been used. Then iron oxide is one of the technology being used in, as I said, sodium hydroxide and the ISET technology. So every technology has certain merits and demerits. So according to the merits and demerits, according to the level of H2S in your biogas and the final level of H2S which is required, you have to select a proper technology. So in fact, for some of our sugar mills, we are doing this work, and we are trying to evaluate the different technologies. So as I told you in the beginning, that transfer of technology is also one of our activity. Coming to CO2 removal technology, there are this is pressure swing adsorption. Our sugar industry is quite familiar with pressure swing absorption. We are using PSA for the ethanol dehydration. So similar kind of technology is also possible for CO2 removal. Of course, here we use different kind of molecular sieve called as carbon molecular sieve, where the CO2, H2O and other gases, they enter inside the sieve, and the methane remains outside, so it comes out of the column, the molecular sieve bottle, and of course there are under pressure, then desorption, and all this kind of pressure swing has to take place to remove the methane again and to release the gases again. So this is the one of the technology, very potential technology available. So in fact, one of our plant which we are now setting up is based on this kind of technology. Then membranes are very effective kind of membranes are available today, and you can see in this diagram there are different kinds of membranes available which are permeable to certain kind of gases. So for example, you can see hydrogen, CO2, ammonia and H2O, they are totally permeable through these membranes, whereas the methane and nitrogen are almost not permeable. They remain in the retention, and if H2S and oxygen is there, partly some of this gas can go into the retention, but that's why we remove the H2S first and then go for the CO2 removal. So there is a company called Evonik. They have one of the best membranes available today, and you can see here the biogas enters. It is a very simple, very convenient, very compact kind of designs are available, and carbon dioxide comes out from the other end and the biogas comes out. We call it as biomethane enriched biogas. So there is a patented technology from Evonik. It is called as 3-stage membrane treatment system, where in the initial stage the permeable gases are allowed to go out, and in the final stage less permeable gases or the retained set are allowed to stay. So this is a very effective. We have installed one latest plant on this technology, but the cost is very high as compared to other technologies. The membranes are also supposed to be sensitive, so there can be the possibility of in case of wrong operation the membrane getting clogged. That important aspect also has to be taken into consideration. So this is the 3-stage kind of membrane separation system. So you can see that finally the methane comes out with more than around 94%. But then there is a certain amount of methane loss also at the bottom, you can see. So depending on the types of different kinds of membranes which are available in the market, you have to select a proper membrane separation system for this kind of application. One very important technology for chemical engineering students will be based on the amine scrubbing, and though it is not yet installed in our country, it is being used particularly in the European countries for the CNG upgradation. So whatever CNG they are getting from Russia, they are using this kind of technology for the CNG upgradation, not to, and then again it is recycled back. So you remove the H2S and CO2, and you get the gas which is almost pure with CO2. Of course, if there is some residual H2S is there, there are certain kind of activated carbon treatment systems which are used to remove this H2S. In fact, one of the Austrian plant, we saw that they are producing CBG also, and they are producing liquefied CO2 also, very high purity CO2. So their economics depends both on CBG production and high purity CO2 production. So this is a very potential kind of technology which can be developed in our country, for production of CBG. Yes, monoethanol amine, diethanol amine, different kinds of amines are there, and there is a lot of literature available on this. And so I have, in this slide, I am comparing this different CO2 removal technology. As I said, pressure swing, water scrubbing. Water scrubbing I have not discussed, but this has been used in one of our plant. Of course, the cost is quite high. The amine scrubbing is one of the, as I said, potential technology in membrane no doubt. But you can see the H2S loss is, methane loss is very less in case of this amine scrubbing. The power consumption is also very important aspect in the cost of production. So one has to compare all these parameters to select a proper technology. Then, as I said, the solid organic manure or the fermented organic manure which will be produced, particularly using, this will be not applicable to the effluents such as spent wash, because for spent wash we have to go for zero discharge. But for the agro residues, for the pressmud cake, we can go for the production of the solid organic manure, and this is based on our results on the pilot plant. We produce around 18 to 20% of the feed as the organic manure, and you can see that it is a very, if you compare the characteristics, it contains lot of organic carbon, it contains lot of organic matter and C/N ratio, and that's why this is going to be very important in future. This kind of organic manure can replace all your chemical fertilizers, and that's why Government of India is promoting this production of organic manure. Similarly, the liquid manure is also very important. We have tested it. We have a very strong agriculture team in our institute which is working on this, evaluating the efficacy of this liquid manure, and it can go as a soil conditioner also. This is the business model given by the oil companies. So in fact, you can produce CBG and put it into cascade, and in future you can put it into the pipelines and then sell it to the oil marketing companies. So this is the model, and you can also set up your own CBG pump. So it is not necessary that you give it to the oil marketing companies. You can also set up your own pump, and if you set up the own pump, they will give you additional 2 rupees and 2.5 rupees for the setting up of the pump and selling it to the. In fact, one of our sugar mill which has started CBG production, they are now setting up 7 CBG pumps, and they will be selling this CBG at a much lower price than the oil marketing company's CNG. And that is because of this latest price which is announced by the oil marketing companies. It was announced in the month of May, and this is valid till 2029. And now they have linked it to the retail selling price of CNG. So CNG price, right now it is somewhere around 90 to 95 at the CNG oil pumps, CNG pumps. So now when we are selling it, we are getting 70 rupees as our price of CBG supplying to the oil marketing companies. But if you have your pump, you can sell it at 70 rupees or 90 rupees also. That is not a problem. So oil company has no objection if you sell it at, so some of our sugar mills which have started producing this, they are planning to sell it at around 80 rupees so that they attract more of the customer toward their CBG pumps. I think these are the CBG models which we have prepared for our sugar industry. They may not be very useful for you. So if you allow me, I will just keep some of the models. These are based on what is the configuration of your sugar mill, your distillery, and most important factor, as I told you, the power which is required in this CBG setup is a very critical factor. And in fact, in our sugar mills, in our distilleries, we are co-generating power. So if you configure, and that is what we are doing now, if we configure our co-generation power in such a way that we can provide steam and power also to this plant, then our CBG production cost will come down substantially. So on the basis of this, we have prepared this model. I will just skip the model. Professor Verma was talking about biocomposting. So we use biocomposting also as a technology for achieving zero discharge. And right now we have the dryers also installed to convert our effluent into a powder. So, but in this case we have the intermediate anaerobic digestion, which can also produce biogas for almost 300 years. This is the last model, which in my opinion is one of the most effective and which will give us the maximum CBG production. And here we can produce CBG from the spent wash also and from the press mud cake, which will be spared if we don't have biocomposting system. So this is the model which will give us the maximum CBG production. We can run it for 350 days throughout the year, because the CBG, if it is produced, you have to supply it to the oil companies for maximum number of days. So one has to run the palm throughout the year without any stoppage. For that purpose, your plant should run 350-360 days. I am giving one case study of the cost of CBG production, and in fact this is based on the spent wash biogas. So we already have biogas plants which are installed in our sugar mills, which are using the effluent from the distilleries to produce biogas. It is a well established technology in our industry, and for example in this case we are producing biogas at a rate of 1000 meter cube per hour, and this biogas contains 58% methane, around 3.5% H2S and 3.5% moisture, and this is the cost of production I am trying to show you. So here we will be able to produce about 10 tons of CBG from this 1000 meter cube per hour biogas, and it will contain 95 to 96% methane, and we will bring down the H2S to almost 5 ppm level. So these are the oil companies require 20 ppm, but with the membrane system we are able to bring it down to 5 ppm also, and this was our capex with civil and everything. So for a 10-ton plant, our capex was somewhere around 17 crore rupees, but it can vary depending on the different kinds of technology which you can employ, depending on your feedstock, depending on your final application. If you are going to generate power from using the biogas, so probably you may not be required to remove the CO2, but you will be required to remove H2S to the level of about 100 ppm. So depending on that, one has to select the proper technology. Here you can see in this slide we are using power of almost 12,750 kilowatt hour per day, and of course we have considered the price of 6 rupees 70 paisa, which is our co-generation power cost, and not the grid cost we have considered, because we generally have in sugar industry our co-generation power available. So we have considered that cost. Even at the 8th row you can see we have considered the cost of biogas also. In fact, if we don't produce CBG, we will be using this biogas in our boiler as a fuel. That is the well established use, and there we are considering 5 rupees per meter cube. So you can see in this cost of production, these two are very important contributors. This is at 5 rupees, this is 1,20,000, and electricity cost at 6.7 rupees, this is 85,000. Other costs are very less, and so you can see our cost of conversion is around 29 rupees from the existing biogas plant. And this is the price of CPG we have considered, and if you come to the simple payback period, it is hardly 1.3 years from the existing biogas plant. Of course, if you want to set up from press mud cake and mixture of press mud cake and bagasse, the economics will slightly differ. In this case, of course, we have not considered CO2 revenue or revenue from fermented organic manure, because this is from the spent wash biodigester where zero discharge is mandatory. So coming to some other important aspects, in fact some of our sugar mills which are producing CBG, they are selling it to the industrial users also. So in fact in Ankleshwar and this area you have a lot of industrial users which can purchase your CBG. In fact, at least 6 months before this revised rates came, one of our sugar industry, where they were getting 46 rupees to the oil companies, they were selling at 61 rupees to the industrial users. So the industrial users can give you a higher price also. The nearness to industrial area can be an advantage. Nearness to the oil companies, CNG plant will also be an added advantage. As I said, not sugar mills, but whoever puts up the CBG plant, they can also set up their own CBG pumps and sell it to the pumps. You can see that many times when we travel from the highways, we see long queues for the CBG pumps also. Particularly not in Gujarat, but in Maharashtra, we have a lot of CNG vehicle coming now, but we don't have that many pumps available. So if you go from Pune to Kolhapur region, you will find on the CNG pumps there are long queues for filling up their CNG tanks. So you can also set up your CBG pump in your vicinity and you can sell it. So your compression cost can also come down if you are not compressing it. Luckily for sugar industry, we have a very well established supply chain for press mud cake and the sugarcane bagasse. So it all comes to our sugar mill and we can use it. In case of other kind of feedstock, municipal solid waste, vegetable waste, the problem is collection, transport and segregation. These are the most important thing. As I said, direct injection in the CNG grid is also possible, and as we go on increasing our grid pipelines, then this will be allowed by the companies. In fact, in Pune we have Mahagas. They are after us. They are asking us to supply it to their grid. As I said, power cost is one of the important factor. If we can supply it from our cogeneration unit, this will reduce our cost of production. Other feedstock availability is also important. Some of our sugar mills which are located in rural areas, they have a lot of cow dung available, and we are feeding press mud cake and sugarcane bagasse along with cow dung, which will help to reduce our feedstock requirement. And of course, the other waste, municipal solid waste, also can be used for co-feeding. As far as sugar industries are concerned, the sugar mill capacity, the distillery capacity, distillery operation days, the existing biogas plant, the availability of the feedstock, that will determine the capacity of the CBG plant. For a typical 10-ton plant, we require about 8 acres of the land, and part of it is used for the sun drying, and of course we can use solar drying also in future if this can be possible. In fact, we have tested through our institute and through some of our sugar mills. There are a lot of diesel to CBG conversion kits available. We have tested it for a good period of time, and they are now available, and one can very easily convert this diesel into CBG kits. So it is a dual fuel. So whenever your CBG gets over, it automatically can switch over to diesel. So there is no problem. And in fact, we are working on this model. The sugar industry has a lot of vehicles, the trucks, the tractors, all they come for the supply of sugarcane. So we can supply them these dual fuel kits, and that will reduce the transportation cost of sugarcane. That is the logic behind it, and therefore some of our sugar mills are going to supply thousands of these kits to their farmers who can put it on their tractors and trucks, and that will reduce their cost of transportation of sugarcane. So coming to final conclusion and the way forward, the various government initiatives which I explained to you, and I am very sure that the central financial assistance is going to come in a different form. So all these government initiatives are very critical for the CBG sustainability. With the announce of Satat program and the latest revision of CBG prices, this scenario is now poised to change, and The fermented organic manure, as I said, will have huge potential in future. It will replace all your chemical fertilizers, and this will definitely going to be a game changer in future. Right now we are considering 3 rupees as the cost of this fermented organic manure, but some of the experts in the fertilizer industry, they say that this can go to 10 rupees also. Then selection of appropriate technologies for anaerobic digestion, H2S removal and CO2 removal are going to be very important. Production cost can be site and technology dependent, and of course the feedstock dependent. And every sugar mill distillery complex will, probably some of you may be familiar that initially we used to have only sugar, then the cogeneration came. Now every sugar mill, to survive them, they have to have an ethanol plant. So without ethanol, only sugar will not be a cost economical aspect, and therefore every sugar mill is now going for the ethanol plant, but in future every sugar mill also will go for the CBG production. In fact, CBG is a perfect case of circular bioeconomy where all waste are treated and recycled back. So that is a perfect case of circular bioeconomy, and as all of you may be knowing that the circular economy is based on 3 pillars of sustainability. So here we have the economic advantage, here we have the environmental advantage, and we also have the social aspect related to this. So it is a perfect case of circular economy, and in fact there is so much of potential in this project today that there are many private companies, there are many funding agencies from Singapore and Gulf. They are ready to set up CBG plants on the BOT basis, provided if you have sufficient quantity of feedstock available throughout the year. So this is what I wanted to bring it to your notice. Thank you very much for your patient hearing. If you have any questions, I'll be very happy to take the questions.